Chapter 7. Chapter 7 is on continuous distributions. So chapter 6 was on discrete. Chapter 7 is on continuous distributions. And this leads us to our one and only one that we give two flying fucks about, our normal probability distribution. All you people that say math class can't be fun, you ain't here. All right, straight up the gate. Stats, calculator, no. You're not doing this shit by hand.
Whoa.
Some of you will do by hand, but not like the distribution part.
Is StatCrunch on the test now or no? The quiz?
On the, oh fuck, I forgot to do that.
So even if it's not, if you go to the copy to clipboard, then usually where StatCrunch isn't often, and you copy it, you can paste it right into StatCrunch, and it'll do the.
So-
It separates them. Yeah, it's set up to like where you copy it with every.
Okay, so the normal distribution is bell-shaped. Which means it's symmetrical. And it has inflection points at plus or minus 1 standard deviation. Now, I'll show you what that means. Like inflection points is like a calculus idea, but it's like really just something on the graph, and you'll see what's happening when I graph it. The things to note are the area beneath the curve, equals 1 for all of them. It is symmetric about the mean. But that means it's symmetric around the mode or median as well. Because for the bell shape, the mean is the median. It increases from left to right, like the number line. And we'll draw graphs, should draw a couple in a second. The important thing, well, not important, but it's good to know that the graph never touches the x-axis. I need you something to write down for a little while. So Like, we might have one that's like this.
Can you move the paper?
That's kind of crooked a little bit. That should be like a vertical hump. But our mean is right here in the middle. And let's say this is with one standard deviation. We might have another graph that's got a different standard number of deviations. It's going to be like flatter, and it goes down slower as we go to the edges. So that may be something like sigma equals 2. As an example. And they can both have the same mean. This looks like your that empirical rule graph we showed you a couple chapters ago. It's the same shape. We get a little bit longer. John Luke could be sketching. You're drawing, aren't you? Oh, you're not? You're just writing information. Okay. It's like, don't say I'm drawing when I'm not. How offensive. All right, I don't see anybody's pin moving anymore. So, we've got this curve, and it's good to know for a given area under the curve, and I'll draw a little curve and show you what I mean. Like if I cut this off right here, and we're looking at that area right there, let's say that's my area. For a given area under the curve between two values, we can say that the area represents it is, you can look at it as this, A, the proportion of the population with that trait. Or B, the probability that a randomly selected person I'm going to say object here because it's not always people from that population possesses the trait. And I realize I've wrote a lot and I need to pause. Don't look, it trips me out. Sometimes, the last one writing, and sometimes like there's 4 pencils still going when he's done writing. I don't understand, there's like a variation in the speed he writes. Or just like, fuck it, I ain't writing this down.
I don't know, it's like, I'm like reading it before I read it down, so I understand it.
All right, everyone ready? I see the pencil stop. Okay, so it's good to know that the homework will often, well, it should tell you because you're going to be in chapter 7, but even on the midterm, homework will often tell you that it is normally distributed. That the data is normally distributed. This is your flag to use normal distribution. And like a lot, I didn't say it last time, Poisson does the same thing. Ooh, that one got a little bite. Don't come up here. You're probably not close enough, but you might be.
Yeah.
Everyone ready?
The range.
I'm in the splash zone. Is that what you're saying?
The disbursement area, yeah.
Contain my feet.
So a common one is the IQ test. We talked about this before. The IQ test has a mean of 100 and a standard deviation of 15. And so they might have you, let me just draw this a little bit. That means my mean goes in the middle. If you go about halfway out, or like halfway where the halfway up that stack, like right here, the hill, that's like 1 deviation. So we have plus 15 or 1 deviation to get to this one. And we keep going in increments like that, 130, 145. This is the empirical rule. We do the same thing going the other way. We subtract 1 deviation, so minus 15. I get 85, 70, 55. Everything all right?
Yeah.
You tip. It might say something like this. You might have like this. Like, let's say we're doing.
Was-
Thank you. What percentage of the population has scores between 85 and 100? No, let's not do 100, let's do 130. Now, usually in 7.1, it might be true for all of the 7.1 questions. Oftentimes, they're asking you to use that empirical rule thing. So that means filling in, looking at that chart. 34% is one deviation away. Then we had 13.5%. That part is 2.35% on both sides. And finally, on the last one, everything past 3 deviations is 0.15%. To find 85 to 130, first off, putting these down and doing that standard deviation thing, adding one standard deviation as you go to the right each time, making these little marks. This is one deviation, the 130 is 2 deviations, the 145 is 3 deviations. So you're just adding 15 each time, or whatever the standard deviation is. Same thing going the other way. This is minus 2 deviations, minus 3 deviations. And I said it, but I might, maybe I'll write down the name so it sticks. Empirical rule model. We got up to percentages. 34 plus 34 plus 13.5. That's in this range from 85 to 130. That ends up giving you 81.5%.
Around 83.5.
Try again. You had me second guessing myself,
I wrote
which
it
means I
sometimes.
either taught it wrong fucking 7 years and didn't know how to add.
I wrote it so fast, I made it look like a 5.
So this 81.5% is two things. It's the percentage of the population that has those scores. It's also the probability that a randomly selected person has an IQ between 85 and 130. You guys ready for more? Nope. Some people are still writing. All right, so I think most of the problems in 7.1 are doing like an empirical model like that. They'll put the little like 1 deviation marks, the 2 deviation marks, the 3 deviation marks when you're looking at it. There's a couple ways to do that. We're gonna hop in StatCrunch in a second. So as a reminder, in StatCrunch, we can do stats, calculators, and normal. And we can either well, without StatCrunch, you could draw it. B, there's a button that says 68, 95, 99.7. If you click that, it will show like the empirical rule. I need to make sure no one started chapter 7 yet. Let me check the grades real quick. Because if so, I can delete some questions. No one started, excellent. Let me change this real quick before we start looking at it. It changes really quick, so it won't take long. There we go. That should remove it. Okay. Some other information you need to know about these continuous distributions. The probability that x equals a specific number for continuous distributions is 0. So you only have three options. In a normal calculator, you can do probability that X is less than or equal to something. Probability that X is greater than or equal to something. And then there's a between option where it's the probability is less than, something number is less than or equal to X, which is less than or equal to another number. So less than or equal to is really the same thing, same value, is just strictly less than, because the equal portion doesn't do anything. And greater than or equal to is exactly identical in value to just greater than. The idea is picture like you're making rectangles, but now you're doing a vertical line and the line has no width. It's just a single line. Area of a rectangle is length times width, but if the width is 0, the area is 0. That's the premise there. So clicking on StatCrunch, and let me show it to you right now. I click stats, calculators, normal. You need the mean and the standard deviation. It defaults to standard normal, which I'll talk about in a second. But you can click on between. And if any of these changes, like if you change from the mean and standard deviation to something different, the 68, 95, 99.7 opens up. It's not there if the mean is when you first open it, because you don't need it first. They already show it as 68, 95, 99.7. So I click on it. Notice right now it says 100, 120, 140. It's showing increments of 20. That's not standard deviation. If I click on the 68, 95, 99.7, now we can see along the bottom, it has the same values I had before. So if you're wanting to speed up how quickly it takes to like set up the empirical rule, you can put your mean and standard deviation in StatCrunch under the calculator's normal and click on that 68, 95, 99.7. All it's doing is saving you from having to do adding and subtracting, but it can't speed it up. Most of 7.1 isn't doing a lot with that. They will ask you questions like this. The weight of a giraffe, the weight of giraffes in general, not just one giraffe, is normally distributed with a mean of 2,200 pounds and a standard deviation of 200 pounds.
It's 2,200 pounds, right?
2,200 and then 200. So mean is 2,200. Standard deviation is 200. They might ask you to pick one of these graphs and find just here, find the one that looks like the empirical rule. which is the same as that 68, 95, 99.7 ticks. In some cases, you're gonna have to use the calculator because they will ask you to do a value that doesn't show up on the standard deviation marks, so you don't know any other way. So it might ask, it might say shade the area to the right of 2,500 pounds. And what does it mean? Or what does it represent? $2,500 is like right there. We're doing something like that. And it means two things. Percentage of giraffes that weigh over 2,500 pounds. LBS is the abbreviation for pounds. I don't know why. There's no L or B in the word pound. That's what we chose for the abbreviation. Ounces has OZ. There's no Z in it. Fucking crackhead came up with this fucking abbreviation system. Or B, the probability of randomly selecting a giraffe over 2,500 pounds. Let's see if any of them have me do this. No, but they might have you do it in the next section, so I'm gonna put it up. Let's go to StatCrunch and figure out what that percentage is. Okay. So I'm gonna come over to StatCrunch and I'm gonna put in that 2,200 and I'm gonna put in that 200. and we wanted the values over 2,500. Notice that kind of looks like what I shaded. And it gives me a value here. I'll switch back to the document camera. But I just wanted to show everybody how to do it. You click on standard, you put in the mean, the standard deviation, you put in the amount, and it is giving me the probability that x is greater than or equal to 2,500 is 0.0668072. If I wanted to write it as a percentage, 6.68%. Everyone ready for some more? Okay, so I don't think they're gonna ask this next part on 7.1, but it does lead into 7.2. 7.2, I believe is on the standard normal deviation. Here, the mean is always 0, and the standard deviation is always 1.
Are we starting 7.2?
Yeah, you put 7.2 if you want. I skimmed the homework and I didn't see anything that talks about z-scores.
Wait, like we have homework that has z-scores?
I think there's gonna be z-scores in 7.2, but I think we've done z-scores in
3 point,
chapter 3, right? We talked about it before, it's gonna show up again. So like the standard normal deviation, the empirical rule has 0, 1, 2, 3 along the bottom that way, and -1, -2, -3. The standard normal deviation, which is the default StatCrunch setting, for normal calculator, has that mean of 0 and standard deviation of 1. These represent z-scores. These are z-scores. So as a reminder, because you did this before, x equals mu plus z sigma. You can calculate z-scores given any x, or given any mean and standard deviation, as z equals x minus mu over sigma. Okay, so let's go back to our giraffes. Let's go back to our 2,500-pound giraffes. Let's z-score the giraffes. As a reminder, their mean was 2,200 and their standard deviation was 200. And we were talking about 2,500 pound giraffes, so we'll say X equals 2,500. But so the z-score is that right there. We're just plugging in the values. Z equals 2,500 minus 2,200 over 200. So that's 300 over 200, which is 1.5. That same thing for z-scores with the giraffe was we were looking at the probability z was greater than 1.5. Pretty sure we'll be done by 3. Everyone ready for more? John, Luke, are you ready?
Yeah.
Never can tell with your pin number. All right, so I hope they don't show this in this edition. They might have hopefully got rid of it. If you see something like Z with a number down here, like Z 1.2, what they're asking for is the probability that Z is less than that number. Or probability that Z is less than 1.2 in the example I gave. If they ask for Z, if Z is mentioned, we're still doing stats, calculators, normal. Leave the mean at 0. And standard deviation at 1. That's how it comes when you open it up. Until you change the mean and standard deviation, that's what it comes as, 0 and 1. So then all you gotta do at that point is it will say X. It means Z. And for the standard calculator, in StatCrunch, it's still gonna say X is less than or equal to something. This is our Z. StatCrunch doesn't change it for this. Son of a bitch, it does have these. That's disheartening. Okay, so it might also say Z alpha. One of them at least does. If it says Z alpha, and it will tell you Z alpha. Like Z 0.13. This one does the greater than. It's the probability that Z is greater than or equal to that value. Ready for more? Okay. So I'm gonna like walk you through a list of some of these. I'm gonna calculate them real quick. You wanna try to do these at home and get the same value. That way you make sure you know how to use your standard normal calculator. Or the normal calculator should be quite a bit on the midterm. It's an important topic. Nope. Those are pretty much the three different setups we have. I'm going to show you the probability that -2 is less than or equal to Z, which is less than or equal to 2. This one right here is like doing like 2 standard deviations on our empirical rule. But you're going to see that it's different. We don't get the same value as 9. On the empirical rule, this is 95%. We get something different here. And then we're going to do some things like this. Probably the Z is greater than, and it'll be blank here, and we're looking for a percentage or a proportion. Here, you guys ready? I'm gonna find these values, show you how to find them and walk through it. And I talk about some more type of problems you'll see. We're gonna go stats, calculators, normal. And I'm gonna leave it at mean 0, standard deviation of 1. The first one I had was greater than or equal or greater than 1.3. So I'll write down the values StatCrunch gives me. This is 0. I don't know, you can see it.
Can you make the graph bigger? Like, can you pull the corner? Yeah.
But it doesn't make the numbers bigger is the problem. And I could try doing this. It makes the numbers a little bit bigger. Does that work? So 0.0968. I'll write down 4 decimals on this. If I do z is less than negative 0.5, I'm getting 0.3085 to 4 decimal places. Now, if we go to the between, we can do the other ones. It starts with negative 1 to 1. Remember on the little thing I said it's 68, 95, 99.7? That's supposed to represent the area for between 1 deviation, then 2 deviations, then 3 deviations. The area between negative 1 deviation and 1 deviation is really 68.27. That's why they say they round it to 68. The empirical rule uses like rounded numbers. And so like, we'll go over like when you should use empirical rule and when you shouldn't. What we were looking at was 2.2 to 1.7. And this is a big number, it's 0.9415. And then if I do negative 2 to 2, like 2 deviations, I get 0.9545 to 4 decimal places. As a percentage, that's 95.45%. It's not that close to 95% because it's like almost as close to 96%, but it's good enough. If we wanted to see the actual values that lead to 95%, we can always change this box over here. So you can change the box on the right to be the target percentage you're looking for. 95% would just be 0.95. Notice that as soon as I did it, it blanked these out. When I click compute, we see that 95% is really 1.96 deviations away. That's pretty close to 2. That's why they say 95% is 2 deviations. If we look at the 68%, that's really close to 1. So that's where they're going with, that's why the empirical rule is there. They're close enough for general stuff. Generally, you don't need much closer for what you're doing if it's empirical rule based. In fact, speaking of stuff like this, let me go back to the standard over here. If we have greater than, the one I had for you guys was the blank 0.14 right here. Oop, I got too many decimals. I'm just going to do 2 decimal places on this when I put it in over here. And I'm going to sketch a quick graph as a reminder of what it looks like. So I'm going to color in the shaded area like they got. Because when I shift back to the paper, I want to talk about it. If I do the less than or equal to, and I put in the 0.32, this gives me negative 0.47 to 2 decimal places. And finally, if I do the between, I had that 0.18. Notice that the values are the same. There's just one is negative and one is positive. This is negative 0.23 to positive 0.23. And if I do this graph right here, let me do the sketch here. Okay, I want to talk about some of these real quick, because these last ones aren't as intuitive. The top ones, they'll just give you shit like, do this. They'll say find the probability z is greater than 1.3. They're fairly straightforward with those problems. The problems that have shit like this top one is, let me call this A. A is like above what z-score represents the top 14%. B says something similar, but it'll say like below 32%, or the 32nd percentile. Because that's how percentile work. Percentile represent the percentage of people or values that are below a certain amount. So if they ask you for a percentile, they'll say like what z-score represents the 32nd percentile. What you're wanting to do is this. Put in 0.32. Put in 0.32 and find what z-scores spit out. And C, the last one. What z-scores represent the middle 18%? Something like that.
Wait, can I see the bottom one?
Yep. Are we having fun yet?
Join us.
That's why we talk about random shit throughout the class. The math isn't always fun. Sometimes it's fun, like the food defect action levels. That was pretty entertaining. Especially when Yvette brought in a chocolate candy bar afterwards. That was great. Good? Okay. So. You might see an example that says we want to drop the lowest and highest 10%. Find the z-score cutoffs. And they might give you some stupid backstory like Gizmo's at a fucking manufacturing company or something like that. Sound like some filler stuff to give it a word problem for them. They're really asking find that, drop the lowest and highest 10%. If we look at that, what they're asking us to do is drop the 10% over here, drop, and drop the 10% over here. Drop that too. If I drop 10% on each side, how much percentage should I have left? 80. I should have 80% in here, right? So if you see this one, you want to do the between, and you want to do the blank less than or equal to z or x. It says x, and you want to put in 0.8. They might ask you for the z-scores that represent a certain percentile. And they might give you a topic like the GRE or something like that, because the GRE exam in high school does percentiles. Here you're just doing probability that x is less or equal to, and then you got your blank, and you're doing 0.82. And you're looking for that amount right here.
Wait, is it not a Z-score in the between part,
What?
in between the, greater than or equal to's? Is that not a Z-score in the middle?
It doesn't say Z in the computer, but it is a Z-score. The computer says X, but that's really a Z. But the computer is gonna say X. I didn't see it on the list. It's not here? That'll be good. Okay, so, in general, if we are looking at Z-score integers, if we are looking at Z equals an integer, like -3, -2, -1, 0, 1, 2, or 3, you want to use the empirical rule. Otherwise, calculate it.
Did I say integer?
Integer, I-N-T-E-G-E-R. And I think that's pretty good for now. That'll give you enough, should give you enough to do chapter 7.2's homework. Now, tomorrow we're gonna do chapter 4 and 7.3. This is graphing with like the XY lines, the shit in algebra that if you ever took algebra, that you had the graphs. You see graphs all the time in the news and shit like that. On Thursday, this is what's gonna happen. You don't have to come in. I'm gonna be here all day from 7 till at least 3. From 7, I'll write this down for you guys so that you can see later. From 7 a.m. on Thursday, midterm day, from 7 a.m. till about 11:30, I will be in John Muir 101. Which is downstairs right next to the elevator.
That's when class will start?
That's when my classes start. I have a class from 7 to 9, and then one from 9:30 to 11:40.
So so can we go to the?
You can come to these, yeah.
And then
If you want to do morning thing and come ask, you can just come be with me all day if you want.
to study for the midterm?
Yes.
Okay.
There are no computers in there though. John Muir 101 doesn't have computers like it does in here. So if you want to, like, I can load up questions on my computer and put it on the projector. But if you want to work on homework and stuff like that, you're gonna have to bring your laptop. Then from 11:30 onward, after I go to the bathroom and stuff like that, I'm gonna move my happy ass up here. Move up to JM 223. If anyone's here, I will stay till 5 o'clock. If no one is here around 3, I'm going home. I suggest you get as much of these homework things done by Thursday. I will answer questions over email. Like if you have a question, do the Ask My Instructor. I'll do them all weekend. But it's easiest if I'm here in person, we can just talk. Okay? So tomorrow we're doing chapter 4 and 7.3. That will not be on your midterm. But I do need to cover the topics so that you know for the semester. I'm supposed to I have shit I'm supposed to teach. That's some of it.
Well, the midterm will be everything that we're going so far.
Except chapter 4, except what I'm doing tomorrow, yes. The midterm will be everything else. And there's practice exams. You can go through the practice. I recommend going through the practice exam a couple times because it might change even the questions. It'll change numbers. It'll give you some practice. It'll show you different types of questions that might show up. It's still hitting the same topics. And if you go through that a couple times and you're doing them under 2 hours. Oh, let me see how long the midterm is. Now that I'm talking about it. Yeah, you have 120 minutes or 2 hours for the midterm.
And there's 25 questions?
Son of a bitch, I should have. Let me look.
And it's class over.
Yeah, you're free to go otherwise.
Have a good day.
You too. The midterm has 24.
Those down to 10.
The review has 28. What'd you ask?
Can we bump those down to 10 questions?
No. I can't cover enough topics in
Questions?
so let me end the recording.